if the limit of g of x approaches c exists, so if I do have a limit that exists in my g function, then the limit of f also exists. So as long as my function that is the one without the hole exists, then the one with the hole will exist, and those two limits will be equal. Alright? Which we've kind of already proven, haven't we? We saw it with the pictures last week, that if you have a hole in the graph, it will have the same limit as the similar function that doesn't have a hole in the graph. Alright, so let's actually find that limit analytically with algebra. Okay, so let's see what the pen will work now. This technology is nothing like that this morning. Okay, so the way we do this is we make an attempt to factor. Anybody remember what kind of factoring I have in the numerator there? It's a binomial. There's two choices when we have two terms. We could do difference of squares. Are those squares? No. That's our other choice, remember? Binomial times a trinomial. Sum of difference of cubes, right? What sign's going to go first? Subtraction, what do my other two signs have to be? Plus, plus, right? So with quick review on cube factoring, it pops up like in the weirdest places in here, okay? And it doesn't pop up very often, but it will pop up in weird places. So remember with cubes, you put your signs in first, whatever sign you start with, that's the sign you start the binomial with, and then the other two are, the last one's always plus, and this one's always opposite of whatever was here, okay? Then we take the cube root of the first term. What's the cube root of x cubed? X, what's the cube root of 1? 1, okay, then we square this, what do we get? X squared, then we square the 1, what do we get? 1, and then I multiply these together with the middle, ignoring the sign, what do I get? X. You can't say you didn't learn that. Most of you had me, we did it the first week of school last year. I just finished teaching it to mathematical stuff last week. Okay? Alright, what happens with these guys? They cancel. You might want to, out of the left-hand column there, write yourself a note that if it cancels, it's a hole. Okay? Which I think we touched on last year. I don't remember right. Because if I were to just put the, so here's why I have to do this. If I were just to put the 1 in there, what would I get in my denominator? 0, which is undefined, right? Which we know that it does have a limit, it's just we can't use that limit. So we have to find something else. Alright, so now I'm down to the limit as x approaches 1 of x squared plus x plus 1. Now can I sub my 1 in there and get a limit? Sure. So the limit, oh, I don't need that anymore. I'm just subbing it. 1 squared plus 1 plus 1. What's 1 squared? 1. What's 1 plus 1 plus 1? 3. Did I get the limit I expected? Yeah, same one as what's on that graph, right? So that's the picture of it. Alright. Let's take a look at another one. So we're supposed to find the limit if it exists, write a simpler function that agrees with the given function at all but one point. We're not going to use it. The instructions always say use a graphing utility to confirm your results. So you could put the function in the graph and actually check out the picture. Okay? We're not going to probably do that. We'll see if we've got time at the end. Alright, I've got to factor that numerator. So right now, I'm not going to help you with the factoring. You should know how to do it. What kind of factoring would I call it? That would be an X, right? So everybody right now, do your X on your paper and you're going to tell me what it factors into. If you know another factoring other than the X, just get a factor. That's all I care about. Yeah. Alright, what do we get for the factors? Okay. Alright, what cancels? So that means your whole would be where? -2. I think there's a typo here, isn't there? There's got to be. Something's got to be a -2. I think this is supposed to be a -2 right here. So fix that. Because if I just had a 2, it would be okay, right? A -2 would not be okay. Alright, so that should have been as it approaches -2. Alright, so we're the limit as x approaches negative 2 of x plus 3. Now what am I going to do with that negative 2? Plug it in, right? So negative 2 plus 3 is 1. Alright, we good with example 2? So the only extra thing we've added today is now we're factoring. Okay? Alright. We have the limit as x approaches negative 2. So I can't put the negative 2 in because it would cancel, right? Or it would be a 0. So I have to find something better before I can find my limit. What does this factor into? Good. Difference of squares factoring. Alright, what's going to cancel? So my whole would be at x equals negative 2. Okay? So I've got the limit as x approaches negative 2 of x minus 2. What are we going to do with this negative 2? Plug it in. So we've got the limit, oh, not the limit, keep writing the notation wrong. Negative 2 minus 2 is what? Negative 4 is where the limit would be. Alright, let's see what we've got here left. Alright, let's do one more together, okay? And I'm going to have you do one on your own. Alright, so if I put in a 2, I would get what in the denominator? 0, right? Because 2 squared is 4. 4 minus 4 would be 0. So I've got to do some factoring. This time it looks like I need to factor both the numerator and the denominator. So, numerator, you're working on it, right? X minus 2, x minus 1. Okay, and then the denominator is what? X plus 2, x minus 2. So what's going to cancel? And what do we call it when it cancels like that? That's a whole. Okay, so when it cancels, it's a whole. So I'm left with a limit as x approaches 2 of x minus 1 over x plus 2. Okay, what am I going to do with that 2 now? Sub it in. So I've got 2 minus 1 over 2 plus 2. What's 2 minus 1? 1. What's 2 plus 2? 4. So 1/4. Alright, there's another one there. I want you guys to try it, and I'll send it out as a quick pull to your calculators, and you can type it in, okay? Once you got it, the poll's coming right now, okay? So make sure you hit enter. Once you've got it typed in, see if you can get it in fraction form even. If you lose the poll, if you go back to your home screen, it should say C is quick poll. Huh? Once you've submitted, you're done, dude. Sorry. You get one shot at these. Alright, I'm waiting for about half of you. Let's get them in quick. About 9 more people. Okay, you got about 20 seconds to get it typed in, then I'm going to shut it off. Last person, be quick. I'm going to shut it off. 5 seconds. Oh, there we go. Okay, let's see what you guys said. Ah, nice. Okay, so I've got 1/2. That one should be right. Okay, and this one I would mark right probably. Let's check it because it looks like a few of us got it wrong. Okay. All right, so let's see. 2 is a common mistake. All right. And can you guys see now with those polls what the common mistake is really quickly? Okay. So, and it's usually algebra and arithmetic. That's what usually kills us. Okay. All right, so let's check it out. We have the limit as x approaches 1. I have to factor it. Do I need to factor the numerator? No. But I do need to factor the denominator. So what does the denominator factor into? Okay, these guys cancel. What's left in my numerator? 1. And then my denominator is, so if you got 2, you dropped your numerator, didn't you? Okay, so we got 1 over 1 plus 1, which is 1/2. Make sure you got the right thing in your notes. Okay. All right, let's look at this next one. Okay, so unfortunately we get a 0 in the denominator automatically, right? And there's nothing that I can factor at this point, right? Okay, so what we're going to do is we're going to rationalize, but kind of the opposite direction, okay? I think we did some of this with trig, where we would have to multiply top and bottom kind of by a conjugate to get it back in the numerator. We rationalize the numerator versus the denominator. So I'm going to use the conjugate though. And I know the conjugate looks way weird, doesn't it? I was showing these to math analysis yesterday and they were flipping out. I had an argument for 10 minutes about a -1. They didn't believe me. Like, it's -1, trust me. Done the problem 10 times. Okay, so I'm going to go ahead on the top. Do I need to do all of FOIL? No, what do I need to do? First and last only. So the radical times the radical is what? Junk underneath, right? X plus 1. What's -1 times +1? -1. Awesome. Okay, in the denominator, I'm going to go ahead, I'm not going to distribute it. I've got x times the square root of x plus 1 plus 1. Because if I distribute it, it's just going to probably end up being more work than it would be. I'm only plugging in a 0, so it shouldn't be that big of a deal. Okay? Before I do anything else, another reason I'm not distributing in, what happens here? They cancel. So now I'm left with the limit as x approaches 0 of x over x times the square root of x plus 1 plus 1. Alright, what happens now? Do you see why I didn't go ahead and distribute in? You have to resist the urge to do what you've always done, right? I tried to knock some of it out of you last year. I'm going to knock the rest of it out of you this year, okay? So, because I would have had to factor that back out. That's a waste of time, all right? So don't be too eager to distribute. So we've got 1 over the square root of x plus 1 plus 1. Now could I sub a 0 into it? Sure. So I've got 1 over the square root of 0 plus 1 plus 1. So this is the square root of what? 1. What's the square root of 1? What's 1 plus 1? And you guys, when I do my work sideways like that, don't follow me. If you can, keep going straight down. Okay, I prefer to see your work going down as much as you can. Okay, not across the page, down the page. Okay? I do it because I run out of room. Wait till we get to a really long problem. Alright, there are some special trig limits, okay, that we need to talk about, and these are basically memorized things, okay? So, if we find, so notice both of them are approaching 0, okay? If we have sine x over x, that equals 1, okay? And it could be this. It could be x over sine x, and it would be 1. The exponents have to match. I could have, as long as I have sine squared x over x squared, that equals 1. Okay? X cubed over sine cubed x, that equals 1. Does that make sense? So on a sine, the exponents have to match, and then it's either sine x over x or x over sine x. The reciprocal works on this one, okay? The other one, this one isn't as popular, but it will probably pop up on the next test. I know this one pops up on the next test. I'm not sure. This one sometimes does, sometimes doesn't, okay? But 1 minus cosine x over x also it ends up equaling 0 when we see it, okay? So when we get down to trig, if we can get one of those two things, we know we can sub in a 1 or a 0, okay? All right, so let's check some of those out. All right. Oh, that's what I should have said. The number has to match as well, right? So if I have a 1 there and a 1 there, I could have a 3 there and a 3 there, it would work. I could have a 2 there and a 2 there, and it would work, okay? Not only does the exponent have to match, but the number in front has to match. So, what's wrong with it? I don't have a 3 in front of that sign, correct? Okay? But I could maybe manipulate it to get something like that. Where am I at? Okay. If I went and I split it up, so the limit as x approaches 0, if I rewrote it as 1/3 times sine x over x, which is just multiplication, I'm allowed to take it apart like that. Now do I have the sine x over x? Yes, okay. So what do we know that turns into? 1. So if I put my 0 in, I know I've got 1/3 times 1, which is just what? 1/3. Okay. Alright, let's try the next one. I didn't say anything about tangent, did I? Alright, but we know that we can take tangent and we can move it into sines and cosines, can't we? So that's what we're going to do with this. So this is really the limit as x approaches 0. I'm going to pull that 1 over x out front for a minute, and what's my tangent going to turn into? Sine x over cosine x. Could I rewrite it a little bit? Could I rewrite it as sine x over x times 1 over cosine x? Sure. What's the limit when I put 0 into that? 1. Okay. Could I rewrite cosine x, 1 over cosine x? What's a better name for that? Secant x, and I'm going to put in secant of, I probably skipped a step on you. Okay. I went ahead and just subbed in my limit, and I did this trig at the same time. Alright, so secant of 0, I'm out here, out 1, up 0. Secant is the reciprocal of cosine. Could I have put the 0 in here and it have been okay? Yeah, okay, I could have done it that way. So what do I get for secant of 0? 1. 1 times 1 is? 1. All that for 1. Okay? Alright. A little bit different. Okay? Remember I told you this number in front has to match, right? So I need to introduce a 4 here. The only way I can do that is by multiplying top and bottom by 4. Okay, so if I multiply by 4 over 4, I'm not changing it anyway, I'm turning it into a 1, right? So now what I'm going to do is I'd have the limit as x approaches 0 of 4 times sine of 4x over 4x. Everybody okay with what I did? I kept this guy out front kind of by himself, and then I put the 4 in the denominator. So as long as these guys match, what's its limit? 1. So I know that's turned into a 1. This stays a 4. What's my limit? 4. Alright, we haven't seen any of the other type yet. There it is. Alright, I'm going to split it up a little bit so you see it better. So we have the limit as x approaches 0 of 5 times 1 minus cosine x over x. What did we say the limit is here as we approach 0? It's 0, so I have 5 times 0, which is 0. Alright, we've got 2 more. One of them's really fun. It's not the next one. Huh? Number 12 is a lot of fun. Okay, we've got sine cubed x, okay? So, could I break this up? Let's try to do that. So I could say that this is sine x times sine x times sine x, right? That means write sine 3 times. And then I don't really need the x over underneath all of them. I could just put it under one of them, couldn't I? All right, now I'm going to go ahead and sub my 0 in. When I sub 0 into this, what do I get for my limit? 1 times sine of 0 times sine of 0. All right, good old unit circle, out 1, up 0. What's sine of 0? Careful. 0. So 1 times 0 times 0 is 0. All that work for a lousy 0. Okay? Wait till we do a whole page and you get a 0. Alright. Let's look at the... That looks ugly, doesn't it? But I gave you one like it in the summer work, right? I told you in the summer work I'm setting you up for something. I'm still setting you up for something here. Okay? For something that we need for chapter 2. Alright? So, we're going to plug into that function. This says we got to use this function and use that formula basically. Okay? So we're going to do the limit as delta, we read that as delta x approaches 0. Okay? This says, what am I going to plug into my function? No, this is the function. What am I going to plug into that function? X plus delta x. So when I see the x, I'm going to plug in x plus delta x and then plus 1. This says I'm going to take my function the way it looks and I'm going to subtract it. Okay, all over delta x. Okay. Now let's go ahead and do our distribution. So I'm going to distribute here and I'm going to distribute that negative at the same time. I still have the limit as delta x approaches 0, which I can't have, right? I got to try to get rid of that delta x in the denominator. So what do I get when I distribute? 3x plus 3 delta x, then that 1's just hanging out, and then I'm going to distribute that negative, minus 3x minus 1. Okay, we can cancel out what? The negative 3x with the 3x, what else? The 1 and the negative 1, so now I am left with the limit as delta x approaches 0 of 3 delta x over delta x. What happens with my delta x's? What's my limit? 3. Looked worse than it was, didn't it? It's learning, and this is why we're doing this. I want you to understand that notation and what you do with it. Okay? Alright, we have lots of time.